First up is Matt Diebel. Matt is a water resources modeler with the Wisconsin DNR, Bureau of Water Quality. He earned his Master's of Science in Water Resources Management and his PhD in Limnology from UW-Madison. His work focuses on large-scale patterns in surface waters, including stream flow, nutrients, and aquatic ecosystem connectivity. So, thanks, Matt.
Thanks, everybody, for coming this morning. As Mike said, my name is Matt Diebel. I'm with the Wisconsin DNR. This is a project that kind of started with some conversations with Mike Kokusko with CARPC. We were working on a similar type analysis for the entire state and had the opportunity to use the groundwater model that was just described to kind of be a little bit more precise about projections of stream flow change that would result from groundwater withdrawals in Dane County. And then look at the potential ecological implications of those stream flow changes. So really the question is not so much how much are the groundwater tables going to change, which this model is really good at, but what is the potential stream flow effects of that, and then the response of the inhabitants of streams, primarily fish. So these are some pictures of the Little Plover River in central Wisconsin that's been kind of the poster child for stream flow depletion and ecological effects. It's dried, as most of you probably know, it's dried up at times, and it's an important brook trout fishery. And I imagine a lot of people are concerned that in the future, if we pump too much groundwater in an area like Dane County, as population grows, that we could see some similar situations. So that was really our objective here, is to evaluate whether that's a likely outcome. So the specific questions were, how will increased groundwater withdrawal affect stream flows in Dane County? You saw a little hint of that in Mike's presentation, comparing pre-settlement stream flows to current stream flows, but we actually looked forward and compared current stream flows to projected flows in 2040. And then secondly, this didn't actually use the groundwater model, but it was part of the project because it's related to stream flow as well. Well, how will planned development affect stream flows if no stormwater controls are used? And that's basically how would it affect peak flows and the resulting effect on fish. And then, as I said, really we're not so much interested in just the changes in flows for flow's sake, but the ecological impacts on fish. So the approach that we used was to, as Mike described, to model changes in stream base flow that would occur using the groundwater model for the county. Then model changes in the April 10% exceedance flow, and that's basically the flow that's exceeded 10% of the time in April. It's kind of an index of high flow, index of stormwater runoff, you could consider it, with a separate regression model. And I'm not really going to get into a lot of the details on some of these models, in particular the regression model, just for sake of time. But if you're interested, I can give you more details later, or we have a technical report that I can share with you. And then model the changes in stream fish communities, basically which species are likely to find suitable flow conditions in the various streams in the county. We have quite a variety of stream types in the county, which I'll get into a little bit in a minute. So just a little overview of stream flow patterns. This is a plot of two gauge streams, one in Dane County, Black Earth Creek, and another just outside of Dane County to the east, the Crawfish River, that show two things. One is the typical pattern of stream flows through the year, where we have higher flows in the spring and lower flows in late summer into fall and through winter. But then also that different streams have different hydrologic patterns throughout the year. Black Earth Creek is a very steady base flow dominated stream that doesn't vary a lot, whereas Crawfish River varies quite a bit, has much higher flows in the spring and much lower flows in the late summer than Black Earth Creek. So the reason why we focused on the April flow for The high flow metric is because that's typically one of the months that has the highest flows, and that's also a period that fish spawn in. At least some of the early spawning species start spawning in April. And the success of reproduction is sensitive to high flows, which can disturb habitat. And then the base flow metric we use is the median August flow, which is typically the lower flow time of the year. It's also a warmer water time that fish are very sensitive to temperature as well. So that's considered sort of the low flow sensitive period for most fish. So we did a big survey of stream base flow in August of 2011. And then this is actually one of the data sets that was used to calibrate the groundwater model. And so this plot shows the measured discharge just on a instantaneous discharge measurement on some day in August of 2011, which was a fairly typical year in terms of rainfall, and plotted against the modeled discharge at each of those sites. So these are about 140 sites across the county. And you can see that there's a good relationship between what's modeled and what was measured. You wouldn't expect a perfect relationship because these were just an instantaneous measurement, and the model is predicting kind of a steady state base flow. But importantly, there's no significant bias. In other words, one is not predicting, or the model is not predicting a higher or lower flow across streams across the county in general. So that means that we can be pretty confident that the model is accurately predicting base flow conditions. We did find that there were a number of very small streams where we measured discharge of less than 1/10 of a CFS that were predicted to have that were predicted to be not perennial. In other words, not have any base flow continually by the model. But these are generally very small headwater streams, again, less than 1/10 of a CFS. And I just wanted to touch on one of the details of how we predicted changes in this April 10% exceedance flow, the high flow metric. And it's basically based on the change in soil permeability that results from increasing impervious surfaces. So the regression model that I'm not going to get into in detail indicates that as soil permeability increases, the April 10% exceedance flow decreases. And an average, the soil permeability without impervious surfaces across the county actually varies. This is the statewide range of about less than an inch per hour up to about 10 inches per hour. And the county actually pretty much contains that full range of soil permeabilities. But if you were to add impervious surface to an area that has a soil permeability of, say, 4 inches per hour and decrease that by half, let's say, then you'd increase the April 10% exceedance flow by about 15%. And then this is the one slide that I'm going to show that demonstrates how the fish response to flow metrics works. These are basically also a form of regression model that uses observed fish distribution patterns across the state. So each of these plots has tick marks on the top and the bottom. Top is presences, and the bottom is absences of that species, and plotted against the median August flow. So, for example, central mud minnow here tends to prefer pretty low, about 1 CFS flow streams, and is really never found in larger rivers. Largemouth bass is sort of a mid-sized stream, and channel catfish prefer larger rivers. And then some species are really more sensitive to flow yield, which is just the discharge divided by the drainage area than the overall discharge. And so these species on the bottom here are examples of those, where brown trout and mottled sculpin prefer higher flow yields, and green sunfish prefers low flow yield. So what we can do is, if we have a stream that in the model is predicted to have a discharge, let's say a flow yield of 0.6 CFS per square mile, and a future development scenario in terms of wells predicts a decrease to 0.4 CFS per square mile, then we can say this is the change in the habitat suitability, or the probability of occurrence of brown trout, from about 0.65 down to about 0.4. So that's basically an index of how good is the habitat for brown trout. So we can do that for all the 80 or so species that occur in Dane County, and kind of sum up the projected effects and come up with basically a fish community change metric that indicates how significant ecologically a flow change would be. All right, so the rest of the presentation, I'm basically going to show you maps. So on here, I'm showing the 1 to 24,000 scale hydrography that we have for the whole state. That's been pruned down to only the extent that the groundwater model indicates perennial flow. So any streams that were predicted to not have perennial flow are omitted from here. And the first map here shows the stream natural community types. And this is basically just to illustrate the variety of stream types we have in the county. As many of you probably know, the western half of the county is part of the driftless area, has mostly cold and cold water streams, a lot of trout streams, where the eastern part of the county tends to have warmer, lower flow streams. The O'Hara River system that bisects the county really starts with small headwater streams and turns into a warm main stem by the time it exits the county. All right, so here's the first simulation map that I'm going to show. So this is the percent of base flow in 2010 that would remain in 2040 based on projected changes in groundwater withdrawal from high-capacity wells in the county. And this is just including, I believe, Mike, correct me if I'm wrong, this is just including the municipal wells, correct? Yeah. So we have all those, Mike Parsons showed the map of all those other high-cap wells, including agricultural wells. But we didn't use projections of changes in those. This is just changes in municipal well withdrawals. So you can see that the majority of the changes here are happening around the city of Madison, where the most growth is expected to occur. Some of the more severe reductions that are projected are the headwaters of Koshkonong Creek here near Sun Prairie. This is Starkweather Creek. This is an unnamed tributary to Lake Wabisa. Headwaters of Deer Creek here. But then that change is quickly offset by a fairly high base flow contribution just downstream. So that's a fairly localized effect. We then projected the change in temperature, and this is July mean temperature, that would likely occur with the amount of base flow change that is projected in the previous map. And you see that there's a few streams that have significant more than 1 or 2 degree Celsius increases in temperature due to the reduction in flow. And that's basically because the flow velocity slows down when you reduce discharge, and that allows more heating from the atmosphere and from the sun. But again, they're fairly isolated areas where we're expecting significant temperature changes. And then this map kind of brings together the temperature and flow changes and all those fish response curves, as I showed earlier, and sums it all up into what we're calling fish community status, and 100% being no change from current and 0 being no more fish. And shows basically where you'd see the most significant changes in fish community across the county. And they're fairly isolated areas, as you probably would have guessed, seeing the flow and temperature change maps. The most significant ones, again, headwaters of Koshkonong Creek, Starkweather Creek, a couple of the tributaries of Starkweather Creek. Actually, the main stem of the O'Hara River has a fish community status of less than 80%, meaning there's more than a 20% change in the overall fish community. And just as some examples of the species we're talking about here, what's a typical species in some of these streams? Central mud minnow, which I showed a plot for earlier, is a typical species in the headwaters of Koshkonong Creek. That's a very small stream. And channel catfish is a typical species in the O'Hara River down around Stoughton. I can vouch for that. I grew up in Stoughton and caught a bunch of channel catfish. So this plot shows basically all the stream segments in the county. It's about 1,000 stream segments if you break it down into reaches of about 1 kilometer in length. And I've plotted the flow remaining in the stream as a percentage of current flow against the fish community status metric. And I guess the good news is that most streams are clustered up here, and that most of the flow will remain and the fish community status will remain high. But you see a number of points that are towards that lower right corner, which is kind of the degradation direction. Koshkonong Creek here, one of the upper reaches, is predicted to basically have no more flow and therefore no more fish. Starkweather Creek is kind of is this one point here. These 2 points that don't have labels, these are unnamed streams. I think one of them is Starkweather Creek tributary. Swan Creek in Fitchburg is this point here. Door Creek, which is a tributary to Lake Higanza. And then a number of reaches of the O'Hara River here, which don't actually have that much change in flow. It's still about 95% of the current flow. But because there's a number of quite sensitive fish species in the river to flow, you'd expect the fish community status to decrease more than the flow would change. So 95% of the current flow results in about 80% of the predicted fish community status. And just as a tangent or a side note to this, some ballpark estimates of flow changes we might see from climate change around the same ballpark mid-century time period would be, and this is really uncertain because of uncertainty in how much precipitation will change and how much temperature will change. But we could see anywhere from maybe a 10% reduction in flow if temperature increases a lot and precipitation does not increase very much. We generally expect to see a little more precipitation. But the range of uncertainty means that we could see an increase in flow that could maybe offset some of these changes, or we could see an additional decrease in flow, which could exacerbate some of these changes from groundwater. I just have a couple more minutes. I'm just checking the time here. So I'm going to wrap up real quickly.
You're fine.
So this is a map where I basically did an experiment where you say, what if we had a 20% reduction in base flow in all streams in the state? What are the sensitivity of those streams to base flow reduction? So regardless of what the projection is based on the groundwater model, where are the most sensitive streams? This is kind of where should we pay the most attention to groundwater if we're worried about stream flow in fish communities? And it really is, it's a lot of the headwater streams in the state, or in the county, but they're pretty scattered around the county, so there's really no part of the county that is completely insulated or resistant, I guess, to changes in base flow. All right, and then switching over to this stormwater or high flow change simulation. As Mike Kukuska mentioned, our current stormwater regulations for the county are basically going to prevent most changes in stormwater and high flows from future development because of the requirements for infiltration and stay on of stormwater. However, if those regulations were not in place and the future development occurred as is projected based on population changes and where those changes would occur, this is the projected change in that high flow metric as a percent of the current value around the county. So basically wherever you see a warmer color here is where we're projecting development to occur in the next 25 years or so. And the change in stream flow that would result from that development if we did not have stormwater regulations. So you can see up to maybe a 40% increase, in other words, 140% of the current April 10% exceedance flow from development, mostly in this area east of Madison. And the fish community status that would result from that change is kind of similar in some ways to the base flow scenario, in that it's not quite as, doesn't look quite as bad as the flow change, and that's because a lot of the fish in some of these headwater streams are just not that sensitive to high flows. And then this is the sensitivity map. In other words, if we had a 20% increase in that April 10% exceedance flow in all streams, where are the streams that would take the biggest brunt in terms of their fish community? And again, it's a lot of headwater streams, and it's also pretty much scattered around the county. So there are sensitive streams pretty much everywhere to that. So this is basically a justification for the ecological importance of the stormwater regulations that we currently have. All right, so just to wrap up, stream flow is, as we've seen in some examples from central Wisconsin and elsewhere, that is really a primary driver of aquatic ecological integrity. Obviously, if you have no flow, we can't have an aquatic ecosystem. But from those plots of fish response to flow, there's a lot of different variation among species to which ones are sensitive. And we can see significant impacts, as I described, for the O'Hare River, even with fairly small changes in base flow. Base flow reduction, based on projected groundwater use through 2040, is likely to cause significant impacts to a relatively few streams in the county. Stormwater regulations, as I just mentioned, will help limit the effect of new development on stream fish. And all this I've put into a spreadsheet tool that CARPC has been using. And as the groundwater model is updated, as new wells are proposed, as development patterns may change, they can incorporate those changes and run new scenarios and get the outputs. And I'd be happy to share that tool with anyone else who's interested. It's a really big file, so just let me know and we'll find a way to get it to you. Yeah, so I'd like to acknowledge Mike, Mike Kukuska, who really kind of spurred this project to happen. Mike Parson, who started coordinating really early in the project between the groundwater model and the surface water components, and Ken Bradbury. Aaron Roosh, Diane Manuz were two DNR LTE employees who helped me with this project, and John Lyons at DNR helped with a lot of the fish pieces, as well as Troy Zorn from Michigan, who has done a similar work in the state of Michigan. So I think we have a few minutes for questions here.
Great. Thanks, Matt. Any questions out there? Try to make the rounds with the mic here again. It's a workout.
I know there are a lot of non-perennial streams in Dane County. Did you look at a percentage of waters that are considered intermittent and what was not included? And also, it would be great to see macroinvertebrates handled in the same way, because I think we'd see a lot more sensitivity.
Right. No, good questions. I didn't calculate the percentage of intermittent streams, but that would be easy to do. My guess off the cuff would be something like 30 or 40% of the stream length, as mapped at the 1 to 24,000 scale, is intermittent. So a lot of the small headwater streams are not perennial, and so not included in this. And no, we didn't do anything with invertebrates, but that would be a nice thing to pursue as a next step. Thank you for the suggestion. Steve.
Matt, for the base flow depletion due to pumping scenario, was recharge constant in the model? In other words, is pumping the only thing that was changed in the model? The reason I ask is, there's the potential to increase recharge with stormwater development done or management done the right way.
I'm going to held constant, yeah. So you're suggesting that if in developments where with good stormwater management we could actually increase recharge
there's at least
from current values?
Theoretically, there's a potential to elevate recharge and partially offset some of those pumping impacts.
Right.
When this seems to stress the importance of doing that.
Yeah, I agree. Yep.
In the low base flow scenarios where temperature changes, like you mentioned the complications of temperature changes in the low scenarios in the summer months especially,
Right.
was that added in, the temperature effects, or was that, you couldn't really add that into the scenario?
It was included.
Okay.
Yeah, so I didn't show the plots, but we have similar fish response curves to temperature, and so it was basically a combination of temperature and flow change that is causing the projected fish community changes.
And with the Friends of Starkweather Creek, and obviously we have a lot to be concerned about, it looks like. At one point, it appears, and I want to make sure I'm saying this right, if there were no stormwater controls and there would be greater flow in the stream, that's actually better for the habitat because we've seen continually decreasing flows, and that has been bad basically for the habitat. That's kind of a correct statement?
Can you repeat the first part
All right.
of that?
Without more stormwater controls, in other words, if there were more developments and they were causing more flow in the stream itself,
It's when the
that
flow-
would make the stream healthier.
Well, it's when the flow occurs. So base flow is generally more the better, although
Right.
that's not true for all fish species. Some actually prefer lower base flows. The high flows that we're using the 10% in April exceedance flow to represent, a lot of more desirable species actually prefer lower peak flows. They prefer more stable stream flow.
Okay. Will there be ways for me or us, our group, to look at this study or this information in more detail about Starkweather Creek?
Sure.
Or even maybe consult with somebody more about the implications here.
Sure, yeah. Maybe talk with Mike Akuska and I afterwards, and
Okay.
we can decide what the best way to do that would be.
Got time for maybe a couple more here? You're good? All right.
All right.
Great. Thanks, Matt.
I'm going to hand this over to
Yeah, if you could just hand it over to Corey.